time today going over questions from probably the assignment because I just do always get a chance to make the answer key out here. So I know some of the questions probably wouldn't necessarily have questions on because they're not really too bad, but I do know there are going to be some that I want to talk to you about. So pencils and calculators, let's get them out here and let's go over some of these here together. Go ahead, Adeline.
7 on the back.
All right, we'll start there, and then I'll kind of go through some in particular that I want to make sure you are checking over, and then tomorrow we'll come in, we'll start the next lesson. Next lesson is kind of piggybacking off of number 2 there, which I'll flip back and talk about number 2 here again in just a few minutes. But we'll start with number 7. All right, you sit on the back.
Yep.
All right, number 7 here on the back.
No, not. Okay, sir, is it up?
It's the number got jacked up or
Yeah, your
something.
numbers are
No
wrong.
problem. Number 6 right here then?
Yeah.
Okay, no problem. All right, on this question right here, we got ourselves, looks like some similar triangles happening. All right, we want to find the distance x there off of that, and then we'll go through and find the length of the ladder, as we can see there. So from here, okay, tomorrow we're going to talk about why we have similar triangles happening off there, why we're allowed to create proportions off that. You may not care why we have similar triangles off that, why we can set proportions. I totally get that. But mathematically, that's what we're going to talk about tomorrow. So playing that matching game first off. So as we look at this here, however you want to set up that proportion, I don't really care. Just start matching up corresponding sides right there. So if you want to take the variable and match up that corresponding side in that smaller triangle, or take the sides that you know in each one and kind of link it together, it does not matter to me. I'm going to take that x right there, and what does x correspond to in that similar triangle on the other one? X goes with 3. So that's what I'm looking for, is that start of that proportion. Either go with x to 3, that's fine, but be consistent. That's all I'm asking for. If I go with x to 3, what am I looking for on the other side of that? 6 to 2, right? Or you could have started off with 6 to 2 equals x to 3. Don't really care. But I need a proportion out of that. Now, we're all kind of right there. We can definitely just see the proportion as well off of that. Finding x, we use our cross product. Excuse me. We use our cross products. But again, you can definitely do that in your head. And what do we get off of that? X is not just 9, but 9. What's our units? We're in feet. Okay. So again, one more time, small things. I am looking for units on our assessments because we do have times where we've done unit conversions. So I am looking for the units to be on there. I will knock off just small points on that. So please put the units if the question has units in there. Okay. Now this ladder here, we want to find the length of the ladder. Now it says the ladder extends 2 feet above the fence and 3 feet behind the fence. So this is a ladder where, this ladder, here's our fence. It just goes over that fence as well. We want to calculate the length of that ladder. So that ladder, again, as I highlight that in my blue, that's what we want to calculate then. Which, on this one, we just got that 9, so let's throw that into that picture. From here, well, it's a good old right triangle, 2 of them. And what's the only thing that we know how to use with right triangles? Good old Pythagorean theorem. So in our next topic, we'll have a backup when Pythagorean theorem doesn't work. But right now, we're still using good old Pythagorean theorem, not just once, but we need to use Pythagorean theorem twice. We got to use on the small, and we got to use on that big one. So with that in mind, let's go with 2 variables there. I'll call that one C, and we'll call that one D. So we'll add those 2 together, and that will give us the length of the ladder. Now, what do we have? 6 and 9, so that does not look like it's going to probably come out necessarily stellar right there, 36 plus 81. So what doesn't necessarily say what around? So if it doesn't say what around there, makes sense to just kind of go with our default here of 1 one decimal. So 10.8. And we're going to add that to what? 2 plus 3. So 2 squared is 4. 3 squared is what? 9. Square root of 13 into my calculator I get. So I get 3.6. And what's 10.8 plus 3.6? So I got about 14.4 feet. Okay. So again, what I'm looking for is when I grade these out, not necessarily just 14.4 feet, especially if that's a wrong answer. I want to see a little bit of work that goes with it. Show me that you realize, oh, I do need to do an extra variable to find me those two hypotenuses off of that. We are way past maybe, what was what I'm looking for? You should be able to do simple Pythagorean theorems in our heads too. Okay, that's what we did with our calculators just now. If you want to sit and write the equation up there, I totally get that. Okay, especially if you missed a mistake. But you should be able to run that through your calculator pretty darn quickly. Show me that 10.8 and 3.6. If you do make a mistake, I can give you some partial credit there. Okay, but that's a good one off of there. Okay. All right, let's take it back, Sam.
For the 3.6 one,
Uh huh.
if you did Pythagorean theorem, would you get like 2 and 3?
I got 13,
Yeah, that's what I got.
just square root of 13, and so just be square root of 13.
Yeah.
Okay, you good there, Sam?
Yeah.
Okay, let's take it back to the other side. This is where I really want to get. I'll talk about any questions, but that's where we're going to kind of go back then with you on the other side. So up at the top there, that's our good old proportions. Question 1, I told you, I don't know if I did or not, but skip, I don't care about question 1, all right? Our proportions there, first thing I notice is our proportions. Question A, that's going to turn out to be our factoring one, I believe. Okay, so let me run through that first one again with you, making sure you can set that up and factor that one. Where I feel like that's going to become a factorable one is when I take x plus 5 times x minus 3. So starting that off, we have a negative 12 happens. And right here, take that binomial times binomial. Now, as I've been grading things here with you on this quiz here, they have been looking good to start off this. So that's very, very promising. So let's keep up with that. I'd say 80% of us are looking good on that. So that's, again, nice to see. What is that? Negative 2x, I think. Put that thing into standard form. And what is that? Negative 3, I think it is. So if somebody else has worked this out already, check my standard form. Tell me if I added or multiplied or did something wrong. But I think that's my standard form there. Yeah, I'm trying to run through this here kind of quickly, so this is not new stuff either. When we factor this thing out, we show how to do our factors of A and C. And the way that this one factors should turn out to be a 3 and a 1. Nope, that's not the right order. Should be a 1 and a 3. And my two solutions should turn out to be a 3 and a negative 1. I believe should be my two solutions there. Okay. All right, question 2 is what I want to check then. That's what we did our first part of the notes yesterday. Do we have similar polygons down there? And that's checking those two things. Are the corresponding angles congruent? And if that's true, we then go over and check to see if the corresponding side is proportional. That is a long effort out of that. We have to check those two things. If that is true, we have similar polygons. If one thing fails, we move on, say they're not similar. Tomorrow, we're going to talk about the triangle parts. And on that triangle part then, we'll take a look at then seeing if we don't have enough information here, we'll talk about some shortcuts. The first thing I notice here is on that top row, A, B, and C of number 2. On letter C, that's not going to be possible. Letter C is not going to be enough information for us. First thing I notice is on number C, do you have any information about the angles on letter C? That's the first thing that jumps out to me. I have no angle information. Corresponding angles are not congruent. So letter C is going to be a no. not similar. And then the next thing would be if you go and write the ratios there as well, the ratios will not turn out to be similar as well, right? So several things are failing on letter C. Now let's walk it back then on letter A. First thing I noticed on letter A, can we match up angle pairs like we did yesterday in our notes? Angle A corresponds to angle X. That's what I'm looking for. Angle B can match up with angle Y. And angle C, triples, goes with angle, what is it, Z? So our angle is congruent. Yep, we're done there. Next thing I'm looking for is, are the sides what? Proportional. So what I'm looking for in you guys is to see if the sides are proportional. So pick a side, match it up, use your calculator if they're crappy to work with. But I'm going to take the side here of 10, which is AB. AB of 10. I know there's not necessarily a lot of room there, but AB of 10, what does AB of 10 correspond to? 1, 2 markings, go with 1, 2 markings of XY. That reduces down to 2, right? So from there, I see that I pick the next side of 12, 1, 3 marking, 1, 3 marking. So 12 goes to 6. So far, so good. And then BC of 2, 3, 2, 3, 14 to 7 reduces also to 2. So we are proportional. We are congruent. So on letter A, what should you have said? You better said that they are similar. Because they are similar, you should have made a similarity statement. I don't care how you name the first triangle. If you wrote ABC, fine. If you wrote CBA, fine. If you wrote BAC, fine. But your second triangle is based off the name of your first one. ABC, then I should be going what? XYZ. And then lastly, you state the ratio. Ratio you've already done. The ratio is written as this order here. So what my case is going to be, the ratio is 2 to 1. Okay, R2, 2 over 1, any of those are fine. Okay. So check your letter A, that's what you should have had as the answer. If you didn't have that as the answer, you did not do any homework last night, shame on you. Letter B. All right, let's look at letter B here. First thing is, on letter B, we do have congruent angles, okay? First thing I notice is these are isosceles triangles. The reason why we know that these are isosceles, we got the congruent angles, Q goes with R. We got the angle markings. And we know that these are isosceles, these are equal, so that implies that these angles are equal to one another. And same thing's happening there. Now, because this vertex angle is congruent to one another, Q is to R, that's going to be the same thing happens down those base angles. Now, what you need to figure out is, are those sides proportional? Does 20 over 3 divided by 4 turn out to be the same thing as 5/3? So this is where your calculator comes into play. Match up 20/3 over 4. Go to your calculator. Does your calculator, do you know how to use it, and change it to a nice fraction? Or go back to 5th grade. I'd rather go with my calculator. I don't want to go back to 5th grade. That was a long time ago. 20/3 divided by 4. Your calculator never returns a nice fraction. It always goes to a decimal. So if we hit math, option 1 changes it to a fraction. Your calculator returns a fraction of 5/3. So I need to make sure that all my sides are turning out to be 5/3. Well, That does 5/3, and what does the bottom one do? 5/3. So the angles were congruent, the sides were proportional. So do we have similar triangles here?
Yes.
Sure do. So letter B should have been a yes. We write up the similarity statement. QMN is similar to triangle what? RST. And the ratio is what we just found to be 5/3. Okay. I don't want to say that's it, but that's it. You got crappy sides like that, let the calculator do the work for you. Letter D should have been a quick, definitely not. Corresponding angles failed. The sides were fine, but the angles is what screwed it up, right? A square and a parallelogram here, the eights were fine. It's a rhombus, okay? But the whatchamacallits, the angles were screwing that up, so not similar. Letter E, the angles look fine. Can you match the corresponding sides correctly and see if they are proportional? So small, small, medium, medium, large, large. Can you match up the sides correctly? On this one here, pick out the small side. Small side of what? 12? What does 12 correspond to in the other one? Now, I'm missing a side over here. That sucks. But what do we know how to find? We can use it with our good old Pythagorean theorem. It's a right triangle. We can find it, use Pythagorean theorem. This might be my small side. It's just that I gotta go find it first. So this has an extra component on there. So a squared plus b squared equals c squared. Gotta go find Pythagorean theorem very quick. So go do that. $28. So that missing side turns out to be 28. It's not my small side, it's my medium side. So 12 goes with 21, small, small. Reduce that by 3. What is that? 4/7? So is everything turning out to be 4/7? Medium, medium. 16 to 28. 4/7. Hypotenuse, hypotenuse. 20, 35. Reduce by 4 again, right? So what's that? No, not 4. Reduce it by 5. And that gives me 4/7. And what do we got? Angles were good. Sides are good. So what do we have? We got another yes. We got some similar triangles going on here. Give me the statement and give me the ratio of 4/7. Okay. So that's where the heavy lifting was. Do we have similar figures? Yes or no? Okay. Tomorrow we talk about a shortcut to triangles, and we don't have all that shortcut information. Okay. But that's tomorrow's objective. Right now we have to go the long way off all that. All right. Now, last one there is rectangles. The angles are fine, but as we saw in our notes yesterday, can you match up the sides correctly again? Small, small, medium, medium, or I guess large, large, I guess. 4 goes with 4, and 9 goes with 6. But is that going to give you the same ratio? No. So this is going to be not similar. Okay. So that's what you should have off of there. All right, down below. I think down below then is using your proportions, just like we did at start this period off with what Adeline asked about. So number 3, I realized number 3, looking at it earlier, z and y, you cannot figure z and y out. We don't know it's a right triangle. And z and y, because they're both the hypotenuse off of that, we don't have anything that you know one of the other on, so we can't use z and y. The only thing you can do on that one is x. We don't know it's a right triangle. Nothing tells me that. So Z and Y we can't do. Just X is all we can do on that one. So scratch out ZY. All right, down below, number 4, we're going to get into drawing pictures. Okay. Street light, street lamp, lamppost. Okay. Cast a 10-foot shadow, while a 6-foot person casts a 4-foot shadow. So think about a street lamp here. Okay. Okay, so you got the light shining down. All right, and a 6-foot person casts a 4-foot shadow. So we're going to kind of do it that same way. I'm going to draw a person here. Now, as we draw these out, okay, think about outside, sun comes down, cast a shadow, sun's rays come out. All right, cast the shadow. You always assume on all these, as we get into our next topic with special rights and trigonometry, these pictures that we're working on here and here as well, they're all going to be like the same type. You are perpendicular to the ground to always create a right triangle. You can't do these without a right triangle. You always assume you're perpendicular to the ground. So when you look at shadows, where do shadows occur? Do shadows occur like right here on the hypotenuse? They magically occur in the middle of flipping nowhere? No, where does a shadow usually occur? Shadow occurs along the ground, right? So when they say it casts a 10-foot shadow, where's that 10 foot going to be labeled on? It's going to be occurred right there labeled along the ground. Your 4-foot shadow, where's my 4-foot shadow going to be labeled at? I don't know how many years I've done it, but I always have like 10% of my kids put my 10-foot shadow right up there. That means like I got shadows like hiding right here. That's weird. Does not happen. You're 6 feet tall. So what's the height? Where's the height going to be labeled? That's my height right there, 6 foot. What do you want to calculate? You want to calculate the height of the street light. So where's the variable going to go? Height's going to go right there. Good eyes, Mark. Now, I'm sorry. Okay. So from there, set up your proportion. Just back what we start off with that one again, what we did yesterday. Match it up. Okay? It goes right back to that what you did on number 5. You are given the picture on number 5. Okay? Maybe separated out the pictures. All right? But it's the exact same setup. H over 6 is equal to what? 10 over 4. You can solve that out. Number 5, for that flagpole, if you need to separate out the triangles, separate out the triangles. But your proportion should be the height of the flagpole to the height of the person is equal to the shadow of the flagpole. What's the shadow of the flagpole? 27. What's the shadow of the person? That's it. They're not going to get any more complicated than what's right there. The only difference is I'm going to take out a couple of those pieces of information and give you some angle information that's going to force us to use trig. But these exact same type of problems are about to come in. We're going to talk about angles of elevation and angles of depression, angles of declination, and we're going to take a look at that when we do trig. But nothing crazy. But these exact same problems start to roll into trigonometry in a few weeks here. Okay? And you better make sure you have a calculator. You can't do trig without the aid of a calculator. So bring it. And on the back side, that rolled us right into that one. And the same thing here on that last one, not even that, because that's just finding missing parts and setting up a proportion to find those last missing sides. Bless you. Now, it looks like that's the last one, isn't it? Okay? So, that finishes it here. You got about 2 minutes or so before the bell rings. If you need to finish off a few of those problems, then turn it in tomorrow. Actually, no, I'm not going to collect them. Turn it in all tomorrow. Just turn it in tomorrow. Just turn it in tomorrow. Okay? And then tomorrow we'll start the next lesson, finish up that assignment if you need to. And that will be it.